Post bag time. What's in it today? Had these a while. Aha, blue LEDs. And forgot what this one said, but I think it was integrated circuits. But turns out to be 1.8 inch SPI TFT modules, which I'm going to use as a temperature display for my central heating controller, my home system. And this one says integrated circuits. Which are to replace a transistor circuit that I've been using as a voltage converter between 5 and 3.3 for ESP286 and other projects. And this one is test tubes. The plan for the test tubes is I've had for quite a while it'll focus on that. I don't know why it comes into focus and that again. They're 75 volts or thereabouts LED strips on modules, and the idea is 2 in per test tube, and to form the test tube into possibly a star or a, I don't know, that's the idea, and as a Christmas decoration for Christmas. And whether I'm going to fuse them together sorry, or a 3D print a centerpiece, I don't know yet. We'll see how that goes. This is the one of the LEDs running about 10 milliamps for it. It's quite bright, nice blue colour, and it's dropping 3 volts across it. So they'll be quite nice for some backlighting or just some general illumination. Well, I was thinking about the level conversion from say a 2.8 volt chip to a 5 volt chip, and normally I would look at something like a transistor circuit, you know, drive the base, look at the collector, but that would give me an inversion. So a 1 going in would give you a 0 going out, because the transistor would invert the signal. But then looking at another circuit, you can have, if you've got like a 2.8 volts on one side, 5 volts on the second, then a simple circuit of 3 resistors and a transistor will do it all for you. So you have a bias chain, a transistor, a pull-up resistor, that's my RX signal. I'll move the 5 volts over here. The ground connected all the way through. The TX signal connected to the emitter of the transistor, and for simplicity we'll have 4K7 resistors, 4 positions, and that's just a generic sort of NPN. Now this works in a simple way, that when the TX input is high, we have 2.8 volts on the emitter, 2.8 volts on the bias chain. Effectively the transistor is off, and therefore the received line is pulled up to 5 volts, so we get 5 volts out. So basically TX 2.8 volts, RX 5 volts. Now when we drive a low signal through, TX becomes low. Now we've pulled the emitter low, we've now got bias current flowing down through the resistor chain and into the base. The voltage across there, base emitter, well, we'll pull up to about 0.6 of a volt. This will turn on the transistor, which will then pull the current down through 0 volts, and so the RX will equal 0. So we've level shifted, we've gone from 2.8 to 5 volts, and we haven't inverted. A high on the input gives us a high on the output, a low on the input gives us a low on the output. And you know, very simple, in one direction, and you know, 4 components. Well, I'm now going to replace that with the chip that came in my post bag, which is an SN74LVC1T45, which is basically a chip that has an A and a B. It has a B volts supply, it has an A volt supply, and it has a direction pin, and effectively it has sort of a level translator that's a bit like that, and the direction just decides whether, if you've got a high, then it drives that way, and if you've got a low, it drives that way. And so with one chip you can do that and a lot faster, because obviously that's limited because it's not designed for high speed, whereas this chip has been designed for high speed. And in a second I'll show you the data sheet. Right, this is the data sheet for the SN74LVC1T45 level translation chip, and as I sort of said earlier in the video, that the maximum data rates 420 megabits per second, so fast enough for most things, and faster I think than the simple transistor and resistor circuit shown earlier. And here it shows it being used in the unidirectional shifter, so level shifter, so that you know, whether you can have this voltage can be down here anywhere between 1.65 to 5.5, and the same on this side. So you know, if this was 3.3 and that was 5, it would obviously level shift from 3 volts to 5 volts. If this is 5 volts and this is 3 volts, then it will downshift. And so, you know, as the direction pin, which is pin 5, is tied to ground, it only acts in that direction. There's an example a bit further down, and this time with bidirectional chips on either end, using the direction control, obviously it now will translate in either direction depending on the control. But I plan to use it mainly in the unidirectional mode as just a sort of quick and convenient level shifter. So, bought on AliExpress, it wasn't that expensive. If I can find the link, I'll put it in the list below. Well, I think that's probably enough for this post bag, and I'll catch you on the next one.